So in this video, we're just going to be building this this JavaScript image slider. It doesn't have to be images, it can be data cards. And so this thing is fully responsive. No matter where we go, it dynamically resizes. There's three types of navigation. We have buttons, so next and previous. We have wheel navigation, like that. And we have mobile or touch navigation. And so this thing is set up for two use cases, desktop and mobile, fully functional on both. Dynamically resizes on mobile. We have the next and previous buttons. And of course, we don't have a wheel on mobile. We have the touch on mobile. So if this interests you at all, stick around. Let's begin. Our Chrome extension development courses have gone live on Teachable. Courses for all skill levels. Chrome extension plus JavaScript web development. Chrome extension development without all that prerequisite JavaScript stuff. And if you just need help reinforcing what you already know, we have a starter projects package. Engaging, curated content, step by step, line by line, preview the courses, join the courses. Okay, so before we get into the navigation, I forgot to actually code up the CSS for the touch area. So let's do that very quickly right here. Let's do .touch area. It's gonna be a margin of 0. Let me just copy all this stuff here. These guys right here. Copy that. Paste that here. The width, we'll just do a 100 viewport width. The height, we'll just do 300 pixels. Position absolute, that's good. Let's do a background color so we can see it of RGBA red. And we'll just do a transparency of 0. Or an alpha 0.2. And a Z index, we'll make sure it's on top of the carousel. Let's go 9999. Save, let's go see what we got. So that's the touch area. If we're in this red zone, we're allowed to scroll with the wheel and with the touch navigation. And speaking of the touch navigation, let's do that first, and then we'll just copy and paste that code, tweak it, and we should have the button and the wheel sorted out. So let's section off the code here. And of course, this is not responsive code. This will be the, what are we doing? We're doing the touch navigation. Okay. So first things first, let's capture that touch area, that red zone. So const, yeah, we'll do touch area is equal to document query selector. And that was .touch area. Then we'll need some lets. So let, we'll do the start position. So where do they start touching the screen? We'll do 0.0. We need a updated position. This is not the updated position of their touch. This is where we should move the carousel. So that's not updated touch position, it's just updated position. That's equal to 0. And we'll need the difference. This is how we're going to know where to move. So this is the final position to move the carousel. This is how much to move it by. So we'll do 0.0. And we'll just do a speed modifier so we can modify how fast the image carousel scrolls based on how they're swiping their finger. And we'll need an array to keep track of where all of the images are. We'll call it last positions. Let's fill that out right now. So the initial last positions, we'll just do a for loop. So for let I is equal to 0. We'll say I is less than images.children. Children.length. Length, we'll do I++. And we'll just push some positions in there. So push, parse, float. It's going to be the images children. Go through them and just take their style.left. So we have all the initial positions of the images. That's how we're going to keep track of it in this array right here. So let's code up the listeners. We're going to need 3 listeners for this guy. So touch area.add event listener. We'll need the touch start. We'll need the event object. And 2 more. 1, 2. So we'll need the touch move. So when they're moving their finger across the screen. And touch end when they take their finger off of the screen. We won't need the event object for the end guy, so we can take that out. All right, so what do we want to do here? As soon as they touch the screen, we want to record where they're touching. So start touch position, event.changed, move my cursor, changed touches. It's an array. So it's the first finger they put down. .screen x, and we want to make sure all the transition durations are set to 0. So let's just copy that code from, where did we put that? Transitions from 0. Did we do that anywhere? Yeah, let's copy this then. Yank this, paste that here. Make sure we bracket it out. All right. So as soon as they touch the screen, we record where they touch, and we set all the transition durations for the images, for the carousel, basically, all to 0. So we have like a 1-to-1 to where there's no lag behind using the CSS. Let's move on to the touch move. So initially, we don't want them to do anything. If we didn't have this and they scrolled, we'd scroll the whole window. So you want to prevent the default behavior of the touch move. We'll move the carousel ourselves. So event.prevent default. Now let's calculate where they're moving to. So const, we need a current touch position for that. Current touch position, same thing. Event.change touches, 0, and it should be .screen x. So we have the current place they're touching. To get the difference, it's just the current place they're touching minus the start position. Let's multiply the difference by that speed modifier. What do we put the speed modifier at? Let's do 0.8, so 80%. So we'll just do a times equal speed modifier, just to slow it down. You can have 1-to-1 if you want. This just, in my opinion, looks better. So speed modifier, and we need to update the start position to be equal to the current touch position. And why is that? Let me draw it quickly. So let's say, no. Can we do larger size, this guy? All right. So let's say this is our start position. This is our current touch position. The difference is how much we need to move the images, the carousel. Now, after we're done using this difference, we need the new difference here. So this would be the current touch position. We update that. We need the first start position to be this guy right here. So we can take this difference. Maybe this is the new current distance. We need to update the start to be this. So we can take this. This is current right here. We need the start to take on this. So we can get the difference here. So we're just constantly updating the start position to be here, then here, then here, then here. So we can get the differences between the two positions. Let me close that. All right, so we have the difference. We've updated the start touch position. Let's actually move this thing. Let me just copy this loop here. And right here. So what do we need to do? We need to calculate actually where do we move. So updated position. So last position. So wherever the images are, wherever the image carousel is at the time, plus the difference that we calculated. Let's move the left value. So we'll do, what are we doing here? Updated position, pixels, and we need to update the array value. So its last position has moved over to the updated position. Equals updated position. There we go. And for touch end, we don't need to code that right now. That's going to be used for the snap back functionality. For now, we'll just leave it like that. So let's save and see what we got. Let's move over to mobile first. Control-Shift-J. Mobile. Let's recenter with Control-0. Let's do an F5. And let's drag. All right, there we go. Now notice how it's not an actual carousel. It's not repeating itself. We'll handle that right now. But in terms of just touching and scrolling, it's good. Let's go back here. And so we need to know two boundaries. So there's a boundary on the right, boundary on the left. When this left image crosses over that boundary, I'm going to take that left image, pop it over on the right. Same thing for the right card. When it crosses some sort of boundary, some sort of threshold right here, we want to take that card, pop it over on the left. So we need a right boundary and a left boundary. And we're going to write a function to handle those boundaries. So let's do this before I forget to call it. Let me just call it right here. Handle boundaries. There we go. Now, what is the right boundary and left boundary? So right, and it's a let because we need to update this dynamically when they resize, because the boundaries change when they resize their window. So right boundary. Right boundary is just going to be the rightmost card plus one width of a card. So we can just do a parse float. We'll do an images.children. The rightmost card is in the number of cards by index. It's the last card. Style.left and plus new width. There we go. And the left boundary is just the opposite. So left boundary is the first card, style.left minus new width. So we have our boundaries. Let's create the handle boundaries function. We'll do that. All our functions are here. Responsive code. We'll do it here. Order cards. Let's do it right here. So function handle boundaries. So all we need to do is check whether or not this last card crosses that boundary or the first card crosses the left boundary. So let's handle the right side first. So if last position, so that's where the last card is, if its position is greater than or equal to the right boundary, we want to do some stuff. Now what do we want to do? Let's first calculate where to put the card. So let's do a const beginning of deck. Beginning of deck. And that's just equal to the last position, so the first card in our last positions array. So wherever that is, minus new width. So in our example here, can I do a control? I can't do it with, can I do it? No, I can't. Let me go to desktop for a second so I can show you guys. Control minus, there we go. Actually, it's not going to work out. How about this? No, it's not work. Anyway, so let's say with the first card's right here, right there. We want to take its position right here and just go one whole card over. So we're placing this card right beside the first card. You'll see it when we actually do it. Control 0. All right, so we got the beginning of the deck. Now let's change this thing visually, and you'll understand why I said visually in a second. I'll show you what's going on behind the scenes in the actual HTML. So let's do an images.children. So we want to transport the last card to the beginning of the deck. So that's the last card right here. Number.style.left is equal to, it's just going to be the beginning of the deck, pixel value. And we need to update its position in the last positions array. So same thing, equal beginning of deck. Let's save. And let's let's go here. Give me the tree. Do I have these labeled? Let me see if I have these labeled so it makes it easier. I don't have these labeled. I need that first. Let's say, where's the HTML here? Let's do this. Let's go. Okay, 1, 2, 3. There we go. ID is equal to, let's say 1, 2, and 3. Save. All right, so let's scroll to the right, and it pops over. Let's keep scrolling, and it doesn't. We'll fix that in a second. Do an F5. Now pay attention to this. Look here. Card 1, card 2, card 3. Let's scroll over. So this is card 3 right here. There we go. So card 3 is visually the first card now. Check out the HTML. It's still 1, 2, 3. So with this code here, we just moved it visually. Where is it? Right. Touch navigation. Right here. So this code here, we just moved it visually. We need to actually go into the HTML and pop this card right here to the back. Same thing with the last positions array. Let me do this. Last positions. Let me see this. So this is the third card here. Right here, excuse me. This is the third card. This guy right here. Visually, it's at the beginning. In addition to that HTML, where we need to take this card, put it up here, so it's 3, 1, 2. We need to actually, or also, go into the last positions array and make sure this 153 guy gets popped back over. So their order that they appear visually is the order that they appear in the arrays. And so to do that, we need 2 new lines. Let's handle what should we handle first? How about this? Let's handle the HTML and then the last positions array. So to do that, we're just going to do an images.append. No, we'll do an insert before. So we want to take the last one that we transferred over visually, so that's the number of cards by index. Just place it before the first element of the array, like that. So that fixes the HTML. For the last positions, we want to do a splice. So we want to make it on the first index, 0. I think it's like the offset or the number of places to move from the first number. Anyways, it's 0, 0. Which one do we want to move? We want the last position, it's not pop. So pop just pops the last element off of the array, and splice puts it at the 0, 0 mark. So let's do this. We'll save. All right, let's go back. Let's go to the elements. Let me do this so you guys can see it in real time. Just pay attention to these 1, 2, 3 numbers here. 3, 1, 2, 2, 3, 1, 1, 2, 3. It just continuously goes like that. Same thing for the, I'm not going to show you the last positions, just trust me, it works. All right, let's go in and code the opposite direction when we do this. So we can just copy all of this logic. And we'll do another if here. So if the last positions, so if the first card is to the left of the left boundary, we just want to do the opposite in terms of our logic. So instead of the beginning of the deck, let's calculate the end of deck. And that's just going to be the last card plus the new width. And we want to switch or move the first card over. 0, 0. Style left, this should be end of deck. This is also end of deck. And we want to insert before, no, we want to do append child. So append the first guy to the end of the HTML tree. So that'd be number of cards by index. Last position splice, start at the end, so last positions. And number of cards by index, move over 0 elements. And to take the first element out of an array, we use the shift method. All right, so we save. Let's see if we got it. All right, so let's go right, and that works. Let's move left, and that works. Now watch this. Let me go, where is it hidden? Let's do this. All right, let's go right. Let's go left. Now watch this. Let's dynamically resize. That's perfect. Let's go right. See what happens. Now what's going on here? Well, we've dynamically resized the carousel. We're not recalculating the boundaries, so let's go ahead and do that. So all we have to do is copy and paste that code right here, this guy right here. So after we resize, after we order, calculate new right and left boundaries, and update the last positions array. So copy all of this. Let's go into our resize event listener, paste it down here. We don't need the let. Do a semicolon here. And of course, we're not pushing in new values to the last positions. We're just updating the values that are already there. So we can take away the push. Just do an I here, equals. There we go. Let's try that again. So we save, go back, let's go right. Let's go left. Let's resize. There we go. All right, so the touch navigation is done. Let's do the button, then the wheel. It's really easy. We just copy and paste all that code and tweak it a bit. Let's section it off like this here. Let's take this guy. Let's go. Let's do it twice. So I'm going to do it again. Yank, paste, paste. Space, space. We'll do a touch navigation. No, this is going to be button. Button, and then we'll do a, what's this going to be? It's going to be the wheel navigation. All right, button navigation. What do we need? Button, 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 button. Let's do a scroll in progress. You'll see why in a second when you write it. Scroll in progress is equal to false. Let me scroll up a bit. I'm not going to capture the buttons because we're only using it once. I'm just going to write it like this. Document. Query selector, and did I give them IDs? I should have. ID previous, I did. All right. Query select. Let's do the next button first. We'll do add event listener. We'll listen for a click. Do we need the event object? We do not. All right. So let's copy and paste all this code here. We don't need the event prevent default. Whatever. Get this, including the handle boundaries call. Take that, paste that here. All right, so we don't need current touch. We're not using touch. We don't need difference. We could have a separate variable for the difference. We don't really need it. Delete that, delete that, delete that, delete that. All right, so it's going to be last position. The position we want to move to is the last position, so wherever it is, plus the difference. What's the difference? Well, when we click the next and the previous, we just want to move one card over. So the difference is just new underscore width like that. So let's save and see if it works. Last bit. Okay. Let's go next. Now notice it's doing that instantly. Let's do this. I forgot to do this. Images children. Let's do an I. That's style, that transition duration. Let's say 0.5 seconds. 0.5. Save. Go back. Next. All right, good. Now notice this. I'm going to spam the next button. See how I can do that? That's why we need that scroll in progress variable to prevent that. So as soon as they click the next, what we're going to do is this. We're going to say, if there's a scroll in progress, just return. So you're not allowed to spam the button. Now, if there's no scroll in progress, we're going to set the scroll in progress to true. We're going to do all the code to move it, 0.5 seconds. And then we're going to wait 0.5 seconds, so set timeout, like this. We're going to set the scroll in progress to false, so they're allowed to scroll again. And that should be 0.5 seconds, 500 milliseconds. There we go. Save, go back, spam the next button. If I spam it on the, watch what happens if I spam it. Very good. So you can't spam it. You can play with the timing, whatever you want. All right, so let's copy and paste that code in the previous, reverse the logic, and the previous button should work. So let me just copy all of this. Let's do a paste here. Okay. We're capturing the previous, click. Same logic here, same logic here. Now, you want to move left, so it's going to be minus new width. That's the same, that's the same, that's the same. Okay. Save, go back. Span the previous. There we go. So we can go previous. Let me turn off the hidden so we can see it. Let's go back up here. Where is it? All right. Spam next. It's doing that thing again. Let's do this. Spam next. There we go. Spam previous. There we go. Let's go to mobile. Do Control 0. This is just the aligning issues when you go from a desktop to, or from mobile to desktop. Control 0 just magnifies it back to 100%. So we can do this. We can go next. Let's do this. We can go next. And the reason it looks funny like that, we don't have the snap back function, so everything's off. It should ideally go center like this. When we do previous, you'll get the proper placements there. All right. So that was the button navigation. Let me see if I forgot anything. Scroll, update the last positions, previous clicks, scroll progress, true, false. All right, let's do some wheel navigations. What do we need for this? We're going to have a mouse over. So they're only going to be allowed to wheel. Let's go back to, since we're using wheel, let's go to desktop mode. Only allowed to wheel through this carousel if their mouse is over this touch area. So we need a variable to keep track of that. And so let's say let mouse over equal false. And we're going to need a mouse, not a mouse, we'll do a wheel timeout ID. You'll see why. It's much the same logic as this. Wheel timeout ID is equal to false. No, let's say null. All right, we need 3 listeners on this guy. We need mouse over, so touch area dot add event listener, mouse over. We don't need the event. Let's do this. Copy, paste, paste. Let's do a space here. Space here. Delete that space. Mouse over. We need the mouse leave, and we need the wheel. For the wheel, we need the event object. All right. So as soon as they put their mouse over, they're going to be allowed to scroll. So mouse over is equal to true. And let's zero out the transition durations. So we can copy that logic from touch start. These guys are here. So as soon as they put their mouse over, they're allowed to scroll with the wheel. And we zero out the transition durations. Now if they leave that touch area, they're not allowed. So mouse over is equal to false. So in here, in this wheel, what are we going to do? Let's do, should we do an event.prevent default? Yes, we should. Event prevent default, and we'll just check that if they're allowed. So if mouse over, then they're allowed to scroll. So let's just copy all of the logic from, the previous whatever. Take this one here, including the handle boundaries. And we'll format. All right, so what's the new difference? It's not going to be a whole width of a card. It's not going to be touch. to get where they're scrolling, we're going to go vertically. So it's going to be in something called the event.delta y. We're going to slow that down by 20% or to 20%, doing that. There we go. Transition duration, we don't need that. Updated position, handle boundaries, if mouse over. And we'll use this timeout ID in a second. So let's save and see if this works. So go back here. There we go. So we can scroll with our mouse. We can do next. We can do touch. Do Control-0 to remagnify. Control-0. We can touch. There we go. Next. All right. So all forms of touch navigation are done. We just need to build in the snapback function. Before we do that, let me set up the logic for that, doing this. So let's start from the end. We'll start here since we're already here. All right, so how do we get after they're done scrolling, how do we get it to call a function? Well, what we're going to do is this. We're going to do set timeout, wheel timeout ID is equal to set timeout. And we're going to call a function called snapback. And we'll do a delay of, I don't know, let's say 100 milliseconds. Snapback. And let me write that function skeleton, or else it's going to give me an error. So function handle boundaries. Let's go function snap underscore back. All right. So every time we scroll, we're going to set a timer to call the snapback function. Now, if we don't cancel this timer, if we scroll 1,000 times, it's going to call snapback 1,000 times. So how do we get this to cancel out every time we scroll? We'll just do this. If mouse over, we'll do this. Clear, timeout, and the wheel timeout ID. So what we're doing here is every time we scroll, we're setting a snapback function to be called in 100 milliseconds. But since we continuously scroll, it continuously cancels out that timeout. The last time we scroll, so when we stop scrolling, this guy gets set. But since we're not scrolling anymore, this guy doesn't get called. And so this guy actually executes that one time. So we just created this little loop, timer loop. So that's good for this. Snapback, snapback. Let's do this. So if mouse is over, and we don't want them to be able to scroll once we're in that snapback animation. So if mouse over is true, and there is no snap in progress, and let me write that variable before I forget. Snap in progress. That's different from the scroll in progress. So let's go back up here. Let's do let snap in progress equal false. There we go. So if the mouse is over the red area and there's no snap animation progress, then they're allowed to scroll. It's the same logic for the next right here. So if there's a scroll in progress, return. If there's a snap in progress as well, if there's a scroll in progress or snap in progress is equal to true, that should be snap in progress is equal to true, then return. Or snap in progress is equal to true, return. Should that be an or? That should be an or. So if mouse is over is true, that should be an and, excuse me, not an or. We'll fix it later if that's the wrong logic to use. It's right here. So once they finish going over to the next card, we don't need to call the snapback animation for the next and the previous because they're actually moving one whole width of a card. So they're actually going to do the snapping in this calculation right here. So we don't need it for that. We need it for this guy right here. Touch end. So if there's a snap in progress, just return, don't do anything. Else call the snapback function. So let me just double check all this logic here. So they're allowed to start to touch. Yeah, we don't really care about that. Touch move, event prevent default. No, we should have those items here as well. So if snap in progress, we don't want to change anything here because it might break. Return, same thing here. And prevent default. Same thing here, same thing there. Snap in progress, return. Good, good. And like I said, if this one blows up, we'll change the ands to ors. If mouse and snap in progress Or I can just do this. Wouldn't even mind it. Let's just do that. So we'll take it out of here. So if there's a snap in progress, don't even worry about preventing default and all that stuff. Or excuse me, clearing timers and all that stuff. Again, if it blows up, we'll just modify. We'll fix it. All right, so we're set up for the snapback animation. So I'm going to have to teach you guys about the animation loop, and we're going to have to do some math. Not difficult, but it can be a bit to wrap your head around. All right, so to get the snapback function fixed or done, we need some more variables. So I'm going to add some guys. We'll do need distance to scroll. So this is going to be how the program knows how many pixels to go left or right in order to center the image carousel. So we're going to save that in distance to scroll like that. Just going to start at 0.0. We're also going to need a seed. This is how we're going to animate the function. You'll see when we'll use it. It's difficult to explain without showing it. So that's it for the lets. We need one more const, and just like we had the speed modifier here, in order to modify the speed of touch, we're going to modify the speed of the snapback animation using a snap speed modifier. We're going to start this guy out at 0.5. That's going to change when I show you the timing functions later. So that's it for the variables that we need. Function snapback. So the first thing we need to have happen when they click or call the snapback animation, we just set the snap in progress to equal to true, so they can't click the button, they can't touch with their finger, scroll with their finger, and they can't scroll with the wheel until we're finished with our animation. So snap in progress is equal to true. And now I'm going to write some code, and then I'll explain it after because it's going to get a bit heady, but I'll do my best. So I'm going to say const adjusted positions, and S, did I spell that correctly? Positions, yeah, is equal to last positions. We're going to do a map. We're going to take each element of that array. We'll call it the position. We're just going to return the absolute value of that position minus the new width divided by 2. And with that array, we're going to find the lowest value in that array. We're going to call that the index of closest card, and closest relative to the snapping point, which you'll see when I draw this thing later. So index of closest cards equal to adjusted index of, and we're just going to use the math.min function to find the lowest value in an array. So which array? We want the adjusted positions there. So now that we have the index of the closest card, let's calculate the distance to scroll. So it's just going to be the adjusted positions and index of closest card. So that's the distance to scroll. We need to know if we need to go left or right. So we have a little ternary doing this. Last positions, index of closest card. Now if that value is greater than the new width divided by 2, then we want to scroll left. So we multiply this thing right here, adjusted positions. We multiply this thing right here by -1 in order to go left. So negative 1.0. Can I do, there we go. Negative 1.0. If not, we just want to go right, so we're just going to multiply it by 1.0. So now that we have the distance to scroll, we're going to call a function, the actual animation loop function. We'll call that animate snap, like that. Let's write the skeleton of it. Function animate snap. All right, so here we go. It's going to be heady. Adjusted positions. Let's discuss this line first, and then this line right here. This is just taking the lowest number in this array, but you need to understand what this array is for this to make sense. So let's go to the whiteboard. And what problem are we trying to solve with that line? Let's do this first. Let me show you guys some values. It'll make more sense. Control-Shift-J. Unexpected token 191. Where is it? 191. Right here. It's a function, not a... There we go. Save. All right. Here we go. So let me do last positions. So these last positions, that array, is where these cards are on screen. So they're at 227.5, negative 227.5, and 682.5. And so these numbers are not arbitrary numbers. Let me show you where we get these. What is the width of one card? 455. What is 455 divided by 2? That's 227.5. And so in phase 1, if you remember, we had to compensate in that order cards function right here. We had to compensate for a transformation up here. We shifted the images, the cards, 50%, 50%. If you remember from phase one, we had to compensate on the back end. The numbers visually, it was in the center of the screen, but numerically it wasn't. So we had to shift things over either left or right by new width divided by 2. That's what these numbers are. They're just the shifts that we did in phase one. So let's go back to the whiteboard and let's do this. So the problem we're trying to solve is which of these cards right here is closest to the snapping point. And the snapping point is not in the center of this card. The snapping point is right here. We want the card, whichever card is the focus, gets snapped to, we want its left border to match up with this border here, because that means the image is in the center of the screen. So how do we get our program to understand that this is the snapping point, and whichever card here, so their top left, X coordinate here, X coordinate here, and there's an X coordinate here. So of these guys right here, of these numbers here, which one is closest to the X value on screen? So let's draw it here. So let's say this is the snapping point, that snapping line. And what's the value of this line? Well, this is the neutral position of our carousel. What's the value of the X coordinate of this image? What's the middle guy, right? So 1, 2, 3. We got 1, 2, 3. This right here, that's the snapping point on the X. So let's do this. 227.5. So for example, the first image starts here, right at the snapping point, like that. The next image starts here, and that value is 682.5. 682.5, and the value of this first card is negative 227. Right here, negative 7.5. So what we're trying to do in this value right here of the card is the same as the snapping point, 227.5. And so we want to ask our program is, which of these numbers is closest to 227.5? Now we could do a lot of complicated math in order to get the program to understand what these numbers are relative to 227.5. But let's just say we ask the program a simple question. What's the lowest value in the array? That lowest value has to be obviously the value or the card that is closest to the snapping point. But if we ask our program that question right here, what's the program going to say? Well, the lowest value is negative 227.5. And so the program would shift all of these images to the right, and this card would go right here. This is not what we want. The carousel is already at the neutral position. It doesn't need to snap to any sort of card. It's perfectly aligned. And so what if we did this? What if we transformed, because currently these guys are on a number line. Let's do green for this number line. And that number line looks like this. Let's say we have a number line. Let me do, what should I do here? Let's do this. Let's say this is the number line. Our snapping point is right here. That snapping point is 227.5. Where are these cards on the snapping or the number line? Well, the 682, that guy's right here. 682.5. Let me do that a bit better. 82.5. This guy falls right on the snapping point. So 227.5. And this guy falls over here. Negative 227.5. And so if we ask our program, which is the lowest value, it says this, and it moves all the cards to the right. This is not what we want. What happens if we transfer or transform this number line to be set at 0? And so the snapping point is a numerical 0. How do we do that? Let's move this guy up. All right, so let's do a new number line. Let's do orange. How do we get the number line to be, you could say, zeroed out? Well, what is 227 right here minus 227.5? Well, it's 0. So on our new number line, we could say if the snapping point continues down like this, we could say 227.5 minus 227.5 is 0. Well, if we subtracted 227.5 from the original snapping point, we have to subtract it from all these values. So this card, it's still visually at the same place, but 227.5 minus 227.5 is 0. So that first card is here, 0. What is 682.5 minus 227.5? Well, it's just half of 682.5. So this becomes, I shouldn't do it like that. It's going to get visually confusing. So this card right here, that's this 0 right here. This card transforms into 227.5, like that. What is negative 227.5 minus 227.5? Well, it's just doubled, right? That's 682.5. So this guy becomes negative 682.5. And so we ask our program, which of these values is the lowest? Not which is closest to 0. Which of these values is the lowest? It says, well, negative 682.5. So it shifts all of the cards to the right. This is not what we want. So let's do one more transformation and then ask the program that question again. Do Control Z. Let me do this. The new number line will do purple. And give me purple. There we go. So new number line. What if we took the absolute value of all of these three numbers on the number line? So our snapping point is still here, which is 0. What is the absolute value of 0? And if you don't know what absolute value is, it's just the positive version of any number. So what's the positive version of 0? Well, it's just 0. What is the positive version of 227.5? Well, it's just 227.5. Now, what is the positive version of negative 682.5? That is 682.5 positive. And we ask our program again now, what is the lowest value in this array? Out of these three options, what's the lowest value? It says, well, it's obviously 0. So let me move the carousel 0 pixels in the left or right direction, doesn't really matter. And we get the behavior we want, which is the carousel stays the same. It doesn't move. So let's do one more example with the numbers not so neat and comfortable, because this was perfect, right? It said 0, so it didn't move. Let's do something where we actually move the carousel. So let's do this. So we did green, orange, purple. We'll repeat that. Green, orange, purple. Green, orange, purple. All right. Let's do green. So this is the number line, the first one that's not shifted or transformed in any way. We still have a snapping point, which starts at 227.5. Let's say every card is 100 pixels over to the right side. So instead of this card starting right here, let's say we start the card here, that middle card right here. And so it would be a 227.5 plus 100. This becomes 327.5. And this card moves over, and that would ideally probably be there. This next card here, what was the value? Forgot already. 682.5 plus 100, 782.5. So let's say this is 782.5, and this first card moved to the right 100 pixels, and that was what? 227.5 negative. So that is what? Negative 127.5. Negative 127.5. All right. So no transformations. We ask our computer program, which is the lowest value. It says negative 127.5, and it shifts all the images to the right. That's not what we want. We wanted to recognize this guy as the lowest value, and then shift all the cards to the left. So this line right here meets the snapping point here. So let's transform or do the first transformation of the number line, which is to subtract or zero out the actual number line. And what color did we say that was going to be? Green, orange, purple. Let's do orange. All right, so the new number line here, this zero out the snapping point, 227.5 minus 227.5. That becomes 0. What is 327.5 minus 227.5? Is that like 100 or something? What is that? 327.5 minus 227.5. Yeah, 100. So this guy becomes 100. I'll write it down here. What is 782.5 minus 227.5? That's 555. So this guy goes all the way down here. That becomes 555. What is negative 127.5 minus 227.5? That is negative 355. So this guy goes down here, and he becomes negative 355. 355. What's the lowest value? This guy moved to the right. That's not the behavior we want. Let's transform it one more time. So we're going to take the absolute values of these guys. And the last number line was purple, right? So there we go. We have our snapping point, or number line centered at 0. The absolute value of 100 is still 100. The absolute value of 555 is still 555. Now, what is the absolute value of negative 355? That's somewhere here. So that's 355. And don't worry about, so the cards are ordered like this, right? First card, second card, third card. But in this, we have first card, we have the second card, then we have the third card, and then we have the, second card, first card, third card. And so they're out of order visually. We don't care. We just care about the numbers. So don't worry that this guy right here went in between these guys when you would expect that it might transfer over here. So we Control Z all of this mess. All right, so we have the absolute version of our numbers. What is the lowest value? Well, it's the 100, right? So it shifts all of the cards to the left, up here. To the left, 100 units. So what should I do with this? Let's go red. No, let's go green. This fuchsia. What is 327.5 minus 100? So shift 100 in the left direction. Well, we get right back to 227.5, which is somewhere, that wouldn't be there. That'd be somewhere like here. What is 782.5 minus 100? That's back here. And what is this value? Negative 127.5 minus 100, that's back to negative 227.5, which is here. And of course, we have the middle card centered. So that's all that line is doing right here. Where are we at? Right here. So we're taking the last positions, which is this guy right here. Those are those numbers non-transformed. We're taking that position. We're subtracting that new width divided by 2, which is the first transformation right here. First transformation right here. Subtract 2, so we're just zeroing out the number line. And we're just taking the absolute value of those numbers just in order to get this negative number to go on the right. So we have all the numbers relative to the 0 here. And then we're asking, what's the minimum value? What's the value closest to the snapping point? And that's the index of the closest card. I hope that made sense, because we're going to move on to the distance to scroll. How do we know? So we know the distance to scroll. How do we know if it's left or right? Because all of these values are now on the right side of a zeroed out number line. Well, that's where this comes in. And so in the adjusted positions, we have, let's just say this. Say last positions 227.5. Let's say our adjusted positions array looks like this. Let me just say let adjusted positions equal, actually we don't need to look like it. We had calculated it over here. So what was that initial thing? It's going to be, which one was it? This one here. So 0, 227.5, 682.5. This guy's the second one. This guy is so it's going to be 682.5, 0, 227.5. So it's going to be 682.5. Where is it? 682.5, 0, and then 227.5. So we have two arrays here. This number aligns with this number aligns with this number, and this number aligns with this number. So we know from the adjusted positions what's the distance to scroll. It's going to be this one right here. Let's say this is not 0. Let's say it's like 10 pixels. How do we know it's 10 pixels if it's 10 pixels in the right direction or the left direction? Well, we didn't touch the signage in the last positions array. We made these all absolute, so we transformed the signage, but we never touched the signage here. So we can take the signage out of this array, apply it to this array, and then we'll know if we're going left or right. So that's all this line does here. So take the minimum value, the actual pixels to move, and just multiply it by, if the last position, so its corresponding value in this last positions array, if it's greater than the original here, if it's greater than the original snapping point, which is 227.5, which is new width divided by 2. So if that number falls to the right of that 227.5, move left. So that's why we have the negative 1.0 here. If it's under 227.5, just move right. So just multiply it by 1.0. So that's all this line is doing. It's taking the distance to scroll, just multiplying it by -1 to go left or 1.0 to go right, depending on where the original number falls on the original number line. So we have the distance to scroll. We call the animate snap. Let's write this this animation loop. And I have to explain timing functions and one mathematical trick. So let's do this. What do we need to do first when we get in here? Well, all of these numbers that we're animating, they're multiple decimal places. We just want to make things simple and keep things to 2 decimal places. So the seed that comes in, we're just going to transform that into parse float, seed to fixed, 2 decimal places. There we go. The next thing we need to do is we need to calculate. Should I write it first? Oh, for this one, I'll draw it first and then I'll write it. So the problem we have with the animation loop, let me go down here, or the right side here. Let's say we have a point here. This is the card here. This is the snapping point here. And this is the distance, the new green for this guy. This is the distance to scroll. So that's the snapping point, distance to scroll. This is where the card is. So this is the snapping point, distance to scroll. This is where the card is. How do we get our program to move from here to here? Well, if we know the distance to scroll, what happens if we did this? Let's say, take the starting point. So I'm just use symbols here. So take the starting point here and add a certain percentage of this distance to scroll. Let's say add this. And so shift the images to here. Let's say orange is where they get shifted to. And let's use a square for that. So shift the images here. And on the next turn of the animation loop, you take that same starting point, but instead of adding just this, we'll go here. There. And so the images end up here. In the next turn of the loop, let me do this. You start here, and let's say we add this percentage of the distance. And then when we get to the very end, we have this starting position. We add the total distance to scroll, and we end up at the snapping point. Now, obviously, this would go the other way. It just makes more sense to go left to right. We'd have all the black X's here, and you just go invert the image, because we started the snapping point here. So that's what we're going to do. We're going to take certain percentages, chunks of this distance to scroll. We're going to add them to this guy right here. And the reason why, I shouldn't say adding, because we're not really adding, and then we're not adding this distance to this distance, or this distance, because then we'd have this plus this would equal like that. What we're saying is always start at the initial point here, and just for every visual turn of the loop for the user, add a certain percentage of the distance to scroll. And we get to the very end, just add the entire distance from the starting point, and that'll be it. It'll make more sense when we do it. So how do we get our program to understand add certain percentages of this distance to scroll? Well, what if we had a seed, and we do have a seed, that went from, let's say 0 to, let's go to 100 for this guy. And we took that seed and we divided it by 100. What is 0 over 100? Well, that is 0%. What is, let's say, 10 over 100? Well, that is 10%. What is 75 over 100? Well, that is equal to 75%. So what if we took this seed and the seed ticks, it goes up by 1? Well, we'll modify it. It just goes from 0 to 100 in whatever increments we want, but it goes from 0 to 100. And so it goes from 0% to, what is 100 over 100? Well, that's 100%. So what if we took these mathematical mechanisms and we multiplied it by the distance to scroll? Let's say in our example, we had 10 pixels, right? Let's say the distance to scroll, green, yeah. And so 10 pixels. What is 0% times 10 pixels? That's 0 pixels. What's in 10%? What is 10% times 10 pixels? What is that? 1? Yeah, it's 1 pixel. What do you do? 75%, 7.5. Let's just say easy numbers. Go 50% of 10 pixels. And that should be green for the 10 pixel stuff. Pixels, that's going to be equal to 5 pixels. And then finally, what is 100% of 10 pixels? Well, it's just going to be the full 10 pixels. So that's how we're going to get the program to take off chunks from the starting point. Give me 0% of the distance to scroll. Give me 10% of the distance to scroll. Give me 50%. Give me 75%. Give me 100% of the distance to scroll. So let's go into the code and actually write this. So we're just going to say let percentage to move equal that seed value over 100. Now this right here is our timing function. We're going to change this later on. You'll see why. So percentage to move, we got a certain percentage to move. Remember, we only want the 2 decimal places. Right now, this is a lot of decimal places. So we're just going to say percentage to move is equal to parse float, not parent. We'll do parse float. And we'll do percentage to move dot to fixed to, there we go. All right, so we have the percentage to move. How do we move the carousel? Well, the same way we've been moving it. So we can copy this code right here, including the handle boundaries. No, I'll show you why we don't copy this when we finish the loop. So let's move the actual images. So updated position is just going to be the last position. So the black X right here plus this formula right here. The percentage to move, use red, percentage to move times the distance to scroll. So right here, we'll just do the percentage to move times the distance to scroll. Images, last positions, we don't need to update this just yet. I'll show you why when we finish this function out. And so the last few things for our animation loop, we need to increase that seed. So the seed starts at 0. We need to increase it by something every turn of the loop. We'll do plus equals 1 times that snap speed modifier. And of course, to make the actual loop, we need to make this function recursive. So request animation frame, animate snap. There we go. So let's see what we get. Save. Let's go back to our image. Let's do a bit of scrolling, do an F5. And it might be difficult to see, but just pay attention to how the carousel is moving. It would be a lot easier if I just did the mobile version. Let's do this. Let's do Control-0. All right. So I'm going to let go. And as you would expect, the first card or the second card here, that's the prominent card. So we want the image carousel to travel to the left. So let go. And that's what we have. And it should stop right there. It's not stopping because we have a recursive function. We haven't built an exit clause or an exit, a piece of exit logic for the loop to know when to stop. So let's do an F5. Let's go back. And so how do we know when this thing should stop? Well, in our math here, it should stop when it takes up the entire distance to scroll. So that's when the seed here is equal to 100. 100 over 100 equals 100%. 100% times our 10 pixel or distance to scroll is equal to the complete distance to scroll. So let's build out that exit logic right here. So if that seed is greater than 100, we know we're at 100% of the distance to scroll. So the first thing we want to do is the snap in progress is done. We're done snapping. So false. We'll reset the seed, 0.0. And we'll do a final move of the carousel. So we copy this, paste that here, and updated positions. We don't need percentage to move. We just want to move the entire distance to scroll now. There we go. We move the image's children. And just like in all of these guys right here, we have to update the last positions. We have to update the last positions. We have to update the last positions. We also have to update the last positions when we're finished moving the carousel. So right here, we'll just do a last positions of I is equal to that updated position. And of course, after we're done moving the carousel, we always want to handle the boundaries. All right, let's see what we get. So Control save. Let's go back. Let's do an F5. Do I need this? No, we'll do an F5 here. Actually, we do need it, or else it's going to take mobile off. All right, let's do an F5. Control-0 to center it. Let's drag and let go. And we wait. And it's not stopping the snap. And why is that? Let's go back here. Seeds greater than 100. Snap in progress. We haven't actually exited the animation loop. So after we handle the boundaries, we're just going to return like that. Save, go back. There we go. So it goes, and it should stop right in the center like that. Let's do this card right here. Soon F5. Let's do this card right here. It should travel to the right. Travel to the right. There we go. And it finishes. All right, so one last thing, and then we're finished. This timing function is a linear timing function. And the seed goes up by the same amount every time. And that time is 1 plus or times the snap modifier. Snap modifier is 0.5. So every tick of our animation loop, it goes up 0.5, 0.10, 0.15, 0.20, 25, 30. So it makes a linear movement. That's why it looks so, I don't want to say ugly, it just doesn't look good. So we're just going to modify this with a different timing function. Let me show you guys this right here. Let's do Control T. Let's go to desmos.com. It's an online graphing calculator. So we're just going to use an easing in function. We're going to simulate that with a quadratic function. So f of x is equal to x squared. X squared. There we go. Let's zoom in here. So what if instead of our seed going from 0, that's not zooming in, excuse me, Control 0. Let's go back to 100% of the screen. There we go. How do we just zoom in on the, do this? Okay, here. What if instead of our seed going from 0 to 100, it just goes from 0 to 1? And so what is 0 divided by 1? Well, that's 0%. What is 0.5 divided by 1? It's 50%. What is 0.75? Somewhere around here. We can do this. 0.75 divided by 1, that's 75%. What is 1 divided by 1? That's 100%. So instead of having the seed go from 0 to 100 and have it move in these 0.5 increments, we're going to tailor our seed to this quadratic function, only using the range from 0 to 1, 0 to 1. And so the animation is going to start out slow like this, and then it's going to shoot up like that. So let's modify the timing function here. And you can use all sorts of timing functions. You could use something like, let me zoom out. If you wanted to, I don't know why you would, but you can use a timing function like this. Times, and then we could speed it up by the x values like that, 40. And if we zoomed in on the 0 to 1, it'd be weird because you'd travel, the carousel would probably go right, left, right, left, right, left, right, left, right, left, right, left, and then end up where it needs to be. Anyways, these are just timing functions. So we're using the second degree or a quadratic function. So instead of this linear guy, we're just going to say math.pow. We're going to have our seed still. And we're going to raise it to the power of 2. And this 0.5 is going to be too quick. It's going to be, I don't want to explain, it's just going to be really quick. So we're going to slow it down by 0.05. And so the exit clause is not seed greater than 100. It is simply seed greater than 1. Save. Let's go back. Let me close this. We don't need that. Leave that. Let's do an F5. And let's do a drag. Let go. There we go. Let's drag. There we go. Drag. There we go. Drag. Let's go desktop version. So I can just, let's do this. Close this. Let's do an F5. And there we go. There we go. There we go. There we go. So that's it for this image slider. It's perfectly, actually, why would I do that? Let's do the overflow off and show the entire thing. Save. Let's do next, next, previous, mouse wheel. There we go. Let's resize. Let's go mouse wheel. There we go. Let's go next. Let's do mobile. Let's do this. Let's go next, previous, drag, let go, drag, let go. There you go. Let's resize. Next, previous. Let's do some dragging. All right, so that's going to be it for the video. It was a really long one, but I think I explained everything I needed to explain. It's perfectly responsive. There's 3 types of navigation. We have the button, we have the wheel, and we have the touch. And probably in future videos, maybe we'll have the buttons also be responsive. But for this tutorial, I think it's good enough. Actually, let's do the responsive buttons now. It's a quick 5 minutes. I'm not going to make another 5-minute or a video just for 5 minutes. So let's convert these guys into images. And I have some images here that we're going to use next and previous. Let me close this. So let's comment these guys out and put our images down. So we're going to need a container for these buttons. We'll call that div. And we'll say nav-buttons-container. And images. So 2 images. We'll say nav-buttons for the class, previous. This guy's going to be, I didn't do 2, excuse me. So image, we'll do nav-buttons. We'll do a previous times 2. This will be the previous guy, prev, tab. This guy will be the next guy. And that should be next. Let's go over here. And this guy should be next. ID. Let's do a split screen so we can see what we're working with. Save. Okay, let's code up the CSS for these guys. So let's start with the nav buttons container, and then we'll do the nav buttons, nav-buttons. The container, much of the same stuff we've been doing this whole video. We're going to center it, so let's just copy this code here. So paste, let me scroll up. Margin 0, padding's good, width, good, height, we don't need, position, good. Let's turn on a color for this guy. Let's go blue. So 0, red, green, blue, 0.3 for this, save. And we want this guy on top of the touch area, so let's do another 9 here. Save. Position absolute. Let's do display of flex for this. So display of flex, we'll do a explicit flex direction of row. We'll do a justify content space between, and we'll align the items center. Save. And the reason why it's screwing up, these guys should be down here, is because we had here. So we took the images in our card. On the CSS, we just coded for the general HTML. So this guy is being applied to the buttons when it should be only applied to the cards. So let's change that here. Class, we'll just do a card-image. Let me do a copy. We'll do a paste. Let's go back up here and change this guy to card-image. Save. There we go. So 2 ways of making this responsive, or we need to make this. Let me go full screen for these guys so you guys can see. We need to make the size of these buttons. I didn't code that stuff. Here, let me do this quickly. So width, each card, or each button needs to take up 50% of the width of the flex container it's in. We want a cursor of pointer so they know they can click on it. And we want to be able to click through this this container. So let me add a pointer events here to none. But we want to click on the buttons. So let's do a pointer events of all. Save, go back, cursor, there we go. So we need to make these buttons, their size responsive, and the placement of them, the width that they're on the screen responsive. So let's go here. Should we capture them? Yeah, let's capture them here. Should be a semicolon there. Let me do a comma there. So we'll say button previous. We'll capture the previous button first. Document.query selector hashtag previous. We'll do that. This should be the next. And this guy will be next. And we need the container. So buttons container equals document. Query selector, we'll do, what was it, .nav-buttons-container, like that. So let's start with the size. We're going to have these guys size relative to the size of the viewport or the card width. And so right here, we're just going to write these lines. Oh yeah, and since we have these listeners, we've coded a variable for these listeners. Let's change that with the buttons down here. Where are the button actions? Here. Instead of doing document right here, this is the next guy. So we'll just do button next. Button next, and this guy's the previous. Let's just go button previous. There we go. And let's change the size. So as soon as we load up the page, we'll change the size, much like we're changing the size of the viewport. So we'll start with the next. Doesn't really matter. Style dot width is equal to, and they're always relative to the size of the width of a card. So we'll do this. And it's going to be half of the card. Each card takes up half of the width of each button takes up half of the width of the flex box. So we'll reflect that here. New width divided by 2. We'll just take up 30% of there. We'll see if it looks good or not. Copy paste. This guy's the button previous. New width percentage. Perfect. Let's save. Go back. There we go. The small cards. Now notice this. Notice the size of the nav buttons don't change when you put that logic in the listener. So we'll just copy these two. We'll go down here. We'll paste it here. Format, save, go back. And there we go. No matter what we do, we are, what would you say, 30% of the width of half of this card. So the buttons actually just grow and shrink. Do I have this logic on? Let me turn this logic off. I didn't like that snapping. We'll have it on in a second. Let me save. There we go. So the size of the buttons shrink. Let's code up so these buttons are 60% of the width of the screen. And if we go below a certain point, then they go to the full width of the screen. Same logic as this guy right here. But instead of the buttons individually, we're just using the buttons container. So we'll do this. Let buttons, let's say placement as percentage. You can play around with whatever you want. I'm just using 60%. It looks pretty good. And we'll have that same clause. Buttons placement is equal to window.inner width, excuse me. It's less than 768. We'll go 100%. Else, just keep it where it is. You turn this guy on as well. Let me increase the size of the images. It just looks better when we go full screen earlier. 800, there we go. And so the buttons container is being sized by, you could say, percentage of the viewport. So it's not going to be the pixel denomination. It's going to be this, tilde viewport width. It's basically percentage, and it's just going to be the button's placement as a percentage. Let's copy this logic and put it in the resize listener. So copy, paste that down here. We'll turn this guy on. We'll take off the let, format, copy this line right here. I took it off there, perfect, and place it right here. All right, format, save, we should be good. There we go, 100%, and that's 60%. Let's turn off the colors. Where are those colors? Let me just control / minimize this. So that's 60%, 100%, 60%, 100%. Of course, it still works. And the wheel still works as well. And let's check mobile. Let's do an F5. It's still, there we go. Still click. It's still resize. There we go. Click, click. There we go. All right, so that's going to be it for the video. It was a long phase. Don't forget to give a like. It helps the channel grow. Subscribe if you haven't already subscribed. And I will see you guys in the next one. I think it's just going to be porting this guy over to the final phase or the first phase, depending on when this video comes out, of the React.js version of this. So I'll see you guys in those videos.